Thank you so much. And in fact, Pietro, I recently checked the SHIELD-6G proposal, and we cited MARE project as one of the projects that we will be potentially collaborating with, and this collaboration happens. So at least we can tick off one of the boxes and say that what we have promised in the proposal is already happening. So thank you so much for the invitation. And yes, as Pietro correctly mentioned, I'm kind of in between the two worlds because one of my legs is still in academia doing the work with the NetSlab team at UCD, and the other leg is in the industry world. And there is a clear reason for this that I will explain in the moment. So just a couple of, I guess, opening lines. Uh, I don't need to explain 6G to anybody here, but maybe whoever is listening that is just thinking about this roadmap from the transition from 5G to 6G, we can clearly say that 6G is not going to be just an infrastructure per se. It's like a nervous system of the society we're going to live in. In fact, depending on which end user I'm speaking to, I sort of say different things about 6G. So when my friends ask me, like, what's great about 6G, I say, well, you don't actually need 6G on, let's say, your device, your phone, because everyone is happy with the 5G and how it works, and our videos are opening, and our downstream, upstream is satisfactory. But there are a number of critical use cases that 6G will be used for, and in SHIELD-6G project, we focus on three particular use cases. One is hospitals, another one is factories, and another one is maritime communication and ports and fleet management that will run on 6G. But of course, this is only one of the three of the many use cases that 6G will support. And the important thing is that an attack on the network becomes an attack on the physical world, because this critical infrastructure will be running on 6G. It will be also exposed to a new set of attacks. So the security has to be sort of in the fabric. I'm happy that Pietro, in his presentation at the beginning, mentioned already a number of enablers, and he mentioned SDN among a few others that I don't have here. That is obvious, but in the project we started to look into some of the new enablers and those old enablers that are maturing and maturing enough to be embedded into the 6G systems. So there's no particular order, and the reasoning here, maybe I'm starting with XAI because this is very close to our heart. But we know that every security threat and its detection, it comes with some reasoning. And the operators or network managers, they need to understand why a model have taken such decision. And of course, this is in combination with LLMs, where the incident reports need to be human understandable, because there's still going to be human in the loop. I mean, this is what we advocate for. We want the networks to be autonomous and zero touch, but not like fully zero touch. We actually want the decisions to be made very quickly, and they need to be spot on. But we still need to have a human oversight and a human decision maker, at least at the beginning of specifying what's expected in our network. We'll have federated learning. There are different kinds. There's centralized, there's decentralized, and everyone here would know, but essentially it's training the model without having to access the raw data. So we will be using this quite a lot in our work. Digital twins, in fact, we have at least 3 teams in the project that have digital twins of the networks, so we can simulate different attacks and defenses on a sort of a mirrored version of the network. Of course, we also in the use cases use digital twins of, for example, an operation room, where we can test some VR performance before we actually deploy it on the actual 5G, 6G network. Our colleagues in Thales and Montimash are looking into honeypots and cyber deception. So this is something that also I believe you will be looking into, because I understood that MARE is heavily looking into, say, a defense layer as like kind of like an attack surface. So we are using this heavily in our architecture that I will be briefly explaining in a moment. But we do build the CTI, and the reason why I put CTI here as enabler as well is because we are going to be using quite a lot of intelligence of the CTI platforms that were built for 5G networks and adapted into 6G. In the numerous presentations today, I have already seen the orchestration and the playbooks. They were mentioned at least a few times. I don't think Sticks and Taxi were mentioned, but Cacao for sure was mentioned, which is the most, I guess, advanced and up to date among the 3. But of course, we would like to exchange this knowledge with this project too, and share the playbooks that we have developed and tested while developing our CTI platform. And then, of course, we have a couple of partners that look into blockchain-based solutions for trust scoring and traceability. So beyond this, there are other enablers, but I just wanted to mention a few of this. Now, of course, the 5G era CTIs that I mentioned were built for sort of a walled garden that does not longer exist. So 6G is pretty much borderless. It is, or we want it to be, autonomous and multi-stakeholder. So the defense for this must be also autonomous and multi-stakeholder. In this case, what 6G is requiring is protection almost everywhere. So we're talking about cloud data centers to end user devices to satellite communication, whichever links are used in the 6G. Of course, in 5G, we were fighting to obtain sort of a minute level or hour level detection of attacks, and then we were trying to minimize the time it takes to fix it. With 6G, we're looking to go towards like sub-second detection and mitigation of the attacks. And of course, we want to protect and cover the largest part of the network as possible. But for this, we need to understand the network, its behavior, and basically simulate before we deploy any security solutions. In addition to this, we need to have live evidence of the actions that were taken. So the auditing part is also extremely important, and it should be for every 6G related project. So when it comes to the CTI platforms, or the CTI platforms that we build, it needs to very quickly decide, act, and learn, and it needs to do it across the entire network, and it needs to do it extremely fast at the machine speed. So it doesn't just defend the network, but it also teaches the network how to defend itself. Now, to the point of SHIELD-6G architecture, this is not what you will find in the proposal, because I didn't want to you go to the fine details of the architecture. This is more of a high level. So as you can see is, and this is nothing unexpected, but when you read this high level architecture, you can see that obviously the data, it comes at the top. It has this curated intelligence. It has this automated flow down the network. And once you collect all of this data and the signals from the network, and again, things like open telemetry was mentioned just a few times previously. And once we understand this, we obviously need AI, right? So like any call, any work call that you join now is about AI, and so is the 6G network. Sometimes I describe it to my non-technical friends as 5G on steroids, and those steroids are essentially AI. So with this, we spot unusual behavior, connect the clues, and explain what was found, noticed, or detected in a plain language. And of course, that language will come at the different expertise levels. Then once you understand what's happening in your network, you act and you do it automatically. So you repair, you execute a playbook, and usually you should have no human intervention here. Once your network is fixed, in a good case scenario, you need to prove that the action that you have taken was reasonable. It actually fixed the problem, didn't just mask the problem. And more or less, that is what we're doing. Of course, if you look at the actual SHIELD-6G architecture, you will see that we collect this information from like every possible source, and that it's a bit more sophisticated than this, but more or less, this is the shape of the architecture, which is not too far from the normal CTI platforms, but it's fit for the 6G architectural concept. And again, when it comes to the concept that I've just mentioned, the philosophy here behind this architecture is that the intelligence feeds the action. The action then is rehearsed and audited, which was a missing part in many 5G CTI platforms. And then that governance feeds the improvements back into the network. And what you get with this is beyond achieving a very reliable network, you also achieve the resilience through this robustness, right? So within a couple of seconds, you can detect, mitigate, and produce some compliance auditing reports. So that's more or less what we try to achieve here. So when it comes to the zero touch that Pietro and his team and the others in the MARE projects would be experts in, and I would believe also this part of the proposal is coming from them. You start with the zero touch ideology in this case is that you start with an intent, right? And this is when you involve a human. So a human sets a particular role, and usually it does it once. For example, let's say I want to specify that my medical VR traffic is critical, and we should never let it degrade, right? And this is usually the last moment that a human or a person is required. Then we operate based on playbooks. So the intelligence layer picks a pre-approved response, like a plan, and I guess like the assurance is the key word here. So every playbook needs to be rehearsed on the digital twin. That's why we need it, or like a digital twin copy of the network before it's even allowed near the live traffic. Then we have enforcement. So the critical thing, we had enforcement in 5G, But the critical thing here is that in 6G, it should be executed in seconds. Or we like to say milliseconds, but let's be reasonable. Seconds is good enough. So you want to either maybe isolate a device, maybe you want to reroute traffic, maybe you want to restore service. But it's done from the data to the edge. So as I was showing you before in the architecture high-level diagram, we want to do it on all of the layers. And once this enforcement is done, we want to do the verification. So the system or the platform needs to check its own work. So did you land the action? Did it help? Did it improve or degrade the service? And while you do all of these checks, you want to keep the evidence and maybe even feed this outcome of the previous action into the next decision. And that's the important loop that we'll have. It's this automation that learns constantly based on the previous actions, maybe previous mistakes as well. So we have close to 40 KPIs, but some of those important ones, as you will see in a moment, is this faster incident response time, the orchestration mode that we want to achieve, and ideally no human intervention. As in any SNS or European project, you want to test your ideas on different POCs and use cases. In case of SHIELD-6G, we have 3. First one led by UCD, and it's essentially a medical use case where we will have a digital twin of the operation room and a digital twin of, let's say, a different part of hospital network that will be used, and along with 3 other partners, we will try to assure some confidentiality on sensitive data, handle the critical data securely, and expose the network to very extreme conditions just to check if our CTI components work. The second use case is on a smart factory. So we're interested in reducing the downtime, whether there is, for example, DDoS attack or another sort of DDoS-like attack. We want to reduce the downtime. We want to detect the threat as fast as possible. In fact, we want to do it in all the 3 use cases, but here it's actually quite important. And the third use case is probably the most advanced in terms of TRL level and the demonstration use case that we have. So this is a multi-hop scenario where you connect sort of a 5G and 6G mesh, and you try to rely less on the satellite communication and defend from things like GPS spoofing, ransomware, and rogue nodes. So LMT is taking care of this use case. I'm also really looking forward to it. So we have 3 live POCs and the use cases in this considered as 6G experimentation facilities. What we try to prove this year and next year is that we can increase the number of threats that are detected autonomously, and that is the keyword, including a high percentage of zero-day attacks. I already mentioned the faster incident response, but also on top of this, we're interested in doing this at a reasonable energy cost. So obviously, let's be honest, if you had to choose either high energy consumption or better security detection, or like security threat detection, you will still choose a better security threat detection as opposed to energy. But lately we try to marry the 2 worlds and achieve similar results with a reasonable energy cost. So we have guys looking into this. Of course, we have the 3 use cases that we want to showcase in this project. And then when it comes to the detection of compliance violation, we want to reduce this time from hours or days to less than 10 minutes. See how it works. You know, this proposal promises never match the expectations one-to-one, but hopefully this KPI will be reached. MARE is a project that is also in SNS, so you are positioned more or less where we are, except that SHIELD-6G is a slightly younger project that just started and kicked off in June of this year. But of course, we built on some expertise gained in other SNS projects, such as confidential 6G, robust 6G, and some of the spatial heritage, which isn't SNS, but we have quite a large team that is also involved in this project. And I just want to say that I know we're going to be discussing probably some future opportunities to work together, but this is really important to somehow communicate as we do today in the SNS project. And actually, I found that this is really difficult to pull off. So just like the webinar today, it may seem easy to organize for someone that is just joining because they got the link, but actually it takes quite a long time to understand who is the other brother sister projects in SNS that you may collaborate with in the future or during the duration of the current project. And there are some facilities in SNS that allow this, but it's still quite tricky to pull this off, to get 2, 3, 4 projects together in the same call and actually exchange information, mainly because the amount of partners is extremely high usually, and the management is just tricky. But there are projects beyond us, like MARE and SHIELD-6G that we can that can work on a similar problem. When it comes to partners, we have 19 partners from 10 different countries, so it's an extremely large consortium. I mean, for anyone involved in HexaX, like Jose Maria or Pietro, this is quite small. But in terms of current landscape of SNS-JU, this is quite a big project. So I encourage you to look into it and to look into what partners do individually here. As a wrap up, I have 2 messages. Well, the first one is that 6G will run on society's most critical services, as I've mentioned, the hospitals, the factories, the government agencies. And SHIELD-6G is trying to make sure that we can defend from different threats, and we can do it in a smart, autonomous, and accountable, auditable way. The second message is that I would like to see some of you, hopefully, in the next EUCNC/6G Summit event, obviously co-organized by SNS-JU. This is going to be in Dublin. It's going to be co-organized by UCD team. So I think for those that have never got opportunity to meet us, it would be amazing to meet and perhaps organize a joint event together if you want to do it during the MARE lifetime or beyond. So again, thank you for this opportunity to speak.